Okay, now we're going to learn 2.4, the ambiguous triangle. Okay, we're going to write down 3 different scenarios, and I know this might not make sense to you. We're going to write it down and then make sense of it. Okay, case 1. If the opposite side is bigger than the adjacent side, it's going to form one triangle. Case 2. If the opposite side is shorter than the adjacent side, and then you're going to have 2 subcases. If you do sine law, and you try to find the second angle, and you get an error, then there's going to be no triangles. If you do the sine law, and you inverse it to get an angle, and you get an angle measurement, then there's going to actually end up being 2 triangles. Okay, so what does this mean? Example 1. Angle A is 41 degrees, side A is 12, side B is 10. Okay, so A is the opposite side, right? Because A and A are opposite of each other. And B is the adjacent side. So this is longer than that, so there's going to be 1 triangle. Okay, so I don't even need to test, I just know that. Why? Why is there 1 triangle? Okay, here's an unknown side, 41 degrees. The adjacent side to A is 10. Okay, pretend my pencil is a length of 10. 12 would be longer. Now, if I swing 12 around, can you see that it's only ever going to swing and touch once? Does that make sense? So there was only 1 possibility. Example 2. We're going to give you the same angle, 41 degrees. A is 3, B is 10. Okay, opposite, adjacent. This is shorter than that. So here I am, I'm shorter than my adjacent, so I don't know which one it is. So we're going to set up sine law. Ready? 3 over sine 41 is equal to 10 over sine. Am I going to get an angle or an error? Okay, 10 times sine 41 divided by 3 equals, don't forget, sine inverse equals error. So there's no triangles. Okay, I'm going to draw you a picture. So here's my, I don't know, angle A is 41 degrees. Adjacent to it is 10. Okay, if this is 10, I'm going to say a length of 3 would be about here, less than halfway. So if you had a length of 3, it's never going to actually reach there. So that's what's happening. It's never going to connect to make a triangle. Okay, last example. 35 degrees is A, side A 7, side B 9. So this one is the opposite, and this one is the adjacent. So I have a smaller than, so I have to test. 7 over sine 35 equals 9 over sine B. Okay, so we go 9 times sine 35 divided by 7. Inverse 47.5 degrees. So therefore, there's going to be two triangles. Okay, we're going to do this whole scenario. First, I want you to take a side note over here. Go into your calculator. What is the sine of 30? 0.5. What is the sine of 150? 0.5. So these had the same result. Do you see anything particular about that? Those angles would make 180 together. Okay, that's an important trig thing. So let's test this. Pick another value. Should we go 40 and 140? Let's test our theory. Those make 180. So do they have the same sine value? 0.6428 sine of 140. Yes. Okay, so in other words, if you have the sine of an angle, it's going to equal the sine of 180, take away that angle. So, if I give you this, if I give you that, here's what you would be doing. Second sine of 0.5, and your calculator gives you 30. But we just talked about that could also be 150. Is your calculator ever going to give you that? No. So you're going to have to provide that. Okay, so in the ambiguous case, that's what's happening. Angle B could be 47.5 or 180 minus 47.5, 132.5. Okay, which means our third angle could be two options. So let's go one triangle, two triangles. Okay, they both have, let's go A, B, C. They both have 35 degrees for A. And we're going to go that angle B is that, angle B is that, are two options. So angle C in this triangle would be 180 minus 35 minus 47.5 equals 97.5. And then triangle 2, 180 minus 35 minus 132.5, 12.5. Okay. In triangle A, side A is 7, side B is 9. I want to know that third side. In triangle 2, side A is 7, side B is 9, and I want to know that third side. Okay? So here's what we're going to do. This triangle, we're going to go like this. 7 over sine 35 is equal to C, I'm going to call it C1, over sine 97.5. Okay, 7 times sine 97.5 divided by sine 35 equals 12.1. So there's one of our triangles. In this triangle, I'm going to go with that 7 and sine 35 ratio, and the side C across from a 12.5 angle. Okay, so 7 times sine 12.5 divided by sine 35 equals 2.64. Okay, so these are my two triangles. Let's draw this out. Okay, I don't know side C. I know angle A is 35 degrees. I know that this length is 9. Okay, here comes the pen. If that's length 9, then 7 would be about this length. So when I swing 7 around, it's going to hit and hit. It's going to hit twice. So swinging 7 around ends up hitting here and here. Okay. Then when we found out that there's an angle across B, there's two options. So look at my diagram. Here's angle B, or here's angle B. Across 9, across 9. Can you see that one is always going to be acute and one is going to be obtuse? So this is 47.5, this is 132.5. Now, in this triangle, the obtuse, we're going to call it the obtuse triangle. Here we go. We have 35, I'm down here, 35, 132.5, and then the third angle is 12.5. You see that triangle? Then when we did the sine ratio, we did 7 over sine 35 is equal to this over sine 12.5. So we got 2.64. Okay, now in the acute triangle, so 9 is across from this angle, right? So that triangle looks like this, 9, 7, and that whole distance. So you can see that angle right here. We did 35, 47.5, and then this top one is 97.5. So when we did the solving over here, we did our matchup 7 across from sine 35, and then we did the length of C across from 97.5, and that was that. Okay, so that's the ambiguous triangle. Two different options for this. There's an acute one and an obtuse one, and follow out your diagram and solving for the two different possibilities for your third side.